In this session, we are going to talk about monitoring of resources in AWS, and the service that we'll be looking into will be CloudWatch. So CloudWatch is a monitoring service built for DevOps engineer, developers, site reliability engineers or the SREs and IT managers. CloudWatch provides you with the data and actionable insights to monitor your applications, respond to system-wide performance changes, optimize resource utilization, and get a unified view of operational health. CloudWatch collects monitoring and operational data in form of logs, metrics, and events, thus providing you with a unified view of AWS resources, applications, and services that run our AWS and on-premise servers. You can use CloudWatch to detect anomalous behaviors in your environment, set alarms, visualize logs and metrics side by side. You can also take automated actions, troubleshoot issues, and discover insights to keep your applications running smoothly. The benefits of CloudWatch are it gives you all the observable metrics on a single platform across various applications and infrastructure. It is the easiest way to collect metrics in AWS and on-premises. It improves the operational performance and resource optimization. You can get operational visibility and insights, and you can also derive actionable insights from logs. So how it works is you have Amazon CloudWatch, which collects the data from your AWS resources, applications, and services that runs on AWS and your on-premise servers. You can monitor them. So you can visualize the application with infrastructure with CloudWatch dashboard, correlate the logs and metrics side by side to troubleshoot and set alerts with CloudWatch alarms. You can act, which means you can automate the responses to operational changes using CloudWatch events and auto scaling. And finally, you can also go and analyze up to 1 second metrics, which can extend up to 15 months with real-time analytics and CloudWatch metric maths. So these are the 4 things that we will be going through when we are working on CloudWatch. We'll be collecting the resources, we'll be monitoring the resources, we'll be acting on them, and we will be analyzing the metrics as and when required. Let's get started with the CloudWatch console. The first thing that you will see inside CloudWatch is on the top, we see the console and we are into the CloudWatch service of AWS. If in case you need to go and find it again, you can either go on the search window and type CloudWatch, which should take you to CloudWatch. Alternatively, you can click on services and inside your management and governance page, you will see CloudWatch. To monitor the resources or the metrics in CloudWatch, if you happen to have any resource, you can click on metrics, all metrics, and it will show you the metrics for all the resources that are being used in CloudWatch at that moment. This will also show you the history of the resources that you might have used in the past. So let's have a look at EC2 and I click on View Automatic Dashboard, and over here I should be seeing the resources which I have, and I can have a look at the resource graph to understand. Let's go and take the resource graph of last 1 hour, and looking at this graph itself, you can understand that the resource is being utilized at 0.07% approximately. Now, because I have set the average of 5 minutes, so the chart over here is segregating it at 5 minutes interval. If you choose to make it less, you can do that also. And now it is giving you the average of each minute. It can be at each second also. If you want, you can have the resource for last 1 hour, last 3 hours, last 12 hour, 1 day, 3 day, week, or basically if you click on the custom window here, you are free to customize it in whatever way you want to view the metrics at that point of time. So let's proceed now. This was the CPU utilization average. Apart from this, you can also have the network packets average. So looking at this, I can understand that the packets had suddenly gone up at 1425 hours, and after that there is basically no traffic which is going inside the instance at this moment. You can also have a look at status check field and status check sum to see if your instance is performing the way it should be. This is basically the monitoring part that we had talked about inside our CloudWatch. You can go and monitor the resources of CloudWatch using this. Next part is to collect the metrics and creating a automated response and analyzing it. So let's go and work on that. Service that we use inside our CloudWatch to be notified if any event has occurred. For instance, if my CPU goes above 90%, I might want to be notified, and this might happen on some specific individual email address, or it can be a particular group's email address. So in this case, if I have to be notified, AWS can certainly help us in doing that using something known as a CloudWatch Alarm, which is present on the left console over here. The AWS CloudWatch Alarm, or a metric alarm, is a result of a mathematical expression based on the CloudWatch metrics. The alarm performs one or more action based on the value of the metric or expression relative to a threshold over a number of time period. This can then send a notification to an Amazon SNS topic. It can perform an Amazon EC2 action or an auto-scaling action, or it can raise an incident in the system manager. In this lab, we are going to focus on sending a notification via a topic. So in case if AWS has to send any notification, that is done via the service known as Simple Notification Service, which is present inside my application integration section on the services tab. Let's go and create a topic. Thereby, we'll go and send emails on that particular topic. The first thing to understand in SNS is, just like CloudWatch, SNS is also a regional service, and this service is available in all the regions of AWS. Secondly, my SNS topic can be used to send the messages to any topic, which in turn can send the message to either an email or a group of email addresses, or as we call it, as a group. On the left, you will see topics. We will go and create a topic over here. We will select the type as standard, and let's call it as alarm-topic-general. Once a topic has been created, anyone who is subscribing or listening to this topic will get the same notification which you are sending on the topic. In this case, you might want to consider a topic as a group in your email, where sending a message to that group is delivered to all the people or to all the email address who are subscribed to that group. Our next step will be to go and create a subscription. For that, I click on create subscription. I will select the email and I will give my email over there to confirm the subscription. The moment I click on create subscription, the person on whom the subscription was added on this particular email ID will get a notification from AWS asking or confirming if they indeed are interested in receiving the subscription, which means you can give any email address over here, but until the person actually goes and subscribes to that email, this person or this particular email ID will not be getting any notification. I can click on the topic name, and inside my subscription, inside my ID, it still says pending confirmation because I haven't done the confirmation of this particular topic as of now. For that, I will open my email ID and I will open it like this. If I do that, it will tell that the subscription is indeed confirmed on this particular topic name with this particular subscription ID. So if I go and refresh the page, I should see the same subscription ID along with the topic name, which is this. Henceforth, if there is any notification that has to be sent, that can be sent on this particular topic. Let's have a look at that. So let's go back to our CloudWatch Alarm or our CloudWatch Management Console. And now we will create an alarm which will be triggered if in case my CPU goes above 90%. For doing that, I will click on my alarms and I will click on choose alarm. So I click here, I select the metric, I select my EC2 console, followed by my instance, followed by the name of the instance on which I have to go and create the alarm on. In my case, I am interested in my monitor-instance, EC2 instance, and I am interested on the CPU utilization. Next step, I will click on select metric. I can give the name over here. This is the instance ID. This graph basically is telling you that how much is this particular metric actually being used. So looking at this, I can understand that the maximum my CPU is being utilized is 0.077%. Next step, I will create an alarm and I will say that whenever CPU utilization in percentage goes above 90, so you will start to see a red line over here. This is basically the threshold. So my CPU right now is the blue line, which is 0.05 or 0.06%, which is being used as of now. However, this is my upper threshold on which I want the alarm to be created. Next step, I will choose that when I want to trigger this particular alarm. So I will select in alarm and I will select my topic, which was alarm topic general. And this will also tell me the email ID on which this particular notification will be sent. If in case you have multiple emails IDs, don't worry, it will be sending it on all those email addresses also. Next step, I'll click on next and I will create an alarm for this. So I am going and naming it as CPU 90. Inside the description, I will say CPU is above 90% and I click on next. Once this all is done, you can click on create alarm and you will now see that our alarm has been created over here, and this alarm basically will be triggered if in case my CPU goes above 90%, which is like this. Right now, because the CPU utilization has to be more than 90 for one data point within 5 minutes, AWS is still working on the alarm. So we'll have to wait for some time and then it will move from this insufficient data to either OK or in alarm. In alarm means the alarm which has been triggered. So if my CPU utilization is more than 90% and the alarm is also for CPU utilization more than 90%, in that case, if my utilization goes to 92%, then my alarm will be triggered. If my notification goes to 95%, then my alarm will be triggered. However, if my notification goes to 80% or the CPU goes to 80%, in that case, it is not an alarm. Rather, that will be a OK state. Right now, as you can see, it now changes from insufficient data to okay. And the reason for that is that at this moment, my alarm is triggered for 90%. However, my CPU is still around 0.06%. This is one way of creating the alarm. There is also another way of creating the alarm, and let's go and check that out now. For that, you can either go to your CloudWatch console and create the alarm from the console, or you can directly go to the service. For instance, I will go inside EC2 and I will create the alarm from my resource itself. For that, I select my instance. And I see my instance, which is monitor-instance coming up. I can click on monitoring and I can create an alarm directly from here also. By default, it is automatically selecting the notification SNS topic for me. And I will say that whenever my CPU goes above 5%, I can trigger the alarm. This can be 5%, this can be 1%, 2%, 2.5%. It can be any numeric value that you want to go for. So I have created another alarm over here. Now in some time, I will see my alarm coming up for this particular CloudWatch alarm also. As you can see, I have two alarms, one which is CPU 90, which I had created from the console, and the second one is this alarm, which is nothing but AWS EC2 hyphen the instance ID, which happens to be this over here, hyphen the name of the attribute which you have selected. In some time, you will see the alarm coming up over here also. And as we did last, this alarm will also go into OK state because right now my CPU is not being utilized at 5%. So let's wait for the alarm to go into OK state, which should happen approximately in 60 seconds. And then we will try to trigger a condition for the alarm. As we can see, my alarm for the 2.5% also is set and it is into OK state. So right now my CPU, because it is not going, it is approximately at 0% itself and my alarm is set for 2.5%. For that reason, my alarms are all set into OK state. This can be seen from the CloudWatch console also, and this can be seen by going into instances, refreshing the instance from here, and I can see both the alarms are in green or in OK state. Now let's go and try to trigger the alarm so that we'll run a process or Docker which will ensure that my alarms are indeed triggered and my CPU goes above the threshold for which the alarm has been created. For that, like you did in the previous module, we are going to go and take help of our Docker instance, and we will install Docker inside the instance, and we will run some heavy-centric jobs inside my Docker container, thereby ensuring that my CPU utilization has been breached. For that, I will open my console and I will split the console in two parts so that I can live monitor how much resources are being utilized. So for that, I click on the connect button. I open the command here and the same command over here. On the left command, I will just type htop so that I can monitor that indeed how much processors are being utilized. You can also press the top command to understand how much CPU is being utilized. However, I prefer htop because it will also show me the course of the CPU. Next command that I will do is I will go and first install the updates inside the instance. And once it is done, I will also go and install Docker inside my instance by sudo apt-get install -y docker.io. -y, as we have done in our Docker class, is to ensure that I am not asked again if indeed I want to install Docker or not. As you can see on the right, my CPUs are indeed hitting 70% and 70%. We have to just ensure that it hits more than 2.5% for the alarms to be triggered. So if we go back to our CloudWatch console as of now, and we click on any of the alarm, let's say the 2.5% one, we will see that my CPU indeed has started to increase. In some time, we will see that it breaches and the alarm has been triggered. Now that my CPU again went down, we will go and run certain services inside my Docker container. So let's go and do that. For that, let's first of all confirm if Docker is installed, and indeed it is. Next step, I will go and run certain images in Docker. So the first one that I run is Mongo. Once my Mongo image has been downloaded and it starts to run in detached mode, my CPUs will again start to increase. Now I'll also go and start running Apache Cassandra or a database. Again, my CPUs will start increasing, as you can see on the right. As you can see now, my CPUs are almost hitting 100%, which means by now our alarm should have been triggered for my machine. For that, let's go back, refresh the page, and I see my alarm has hit in alarm. So the blue line, which was generally around 0%, has straight away gone to 38%, which means my alarm of 2.5% has been breached. To confirm that, I can click on in alarm and I see that yes, this alarm is in alarm state. Next step, if we want to confirm what action was taken, we can click over here, scroll down, and it says that from OK state, it went to in alarm, which means I have successfully sent the notification on my SNS topic, which is this. And indeed, on my email, I got a mail which gave me the message telling that this particular alarm is triggered. Let's have a look at the email. As you can see, I indeed get an email where it says that this particular alarm has been triggered, which was triggered at 2.5%. So this is how you can create alarms in CloudWatch, and you can ensure that the alarms are taking some action based on whatever things or whatever the metrics for the alarm were. Let's go back to our EC2. And if I click on instances over here inside the alarm status, it will start to show me in red that 1 out of 2 alarm has been triggered because my CPU is still around 20% only and not 90%. So for that reason, CPU 90 is in okay state and this hasn't been triggered, whereas the CPU 2% has been triggered for me. In certain scenarios, you might want to run some stress testing on the machines to ensure that whether the machine will actually trigger the alarm on certain scenarios. For that, we have a tool which we can use in Ubuntu, which is known as Stress. To install that, just go and type sudo apt-get install stress. It will now go and install the stress software or program inside your machine. If in case you have to go and stress your system, let's have a look on the right over here. My CPUs are at 1.3 and 0%. So basically it's around 1% itself. To stress the system, I just have to go and type sudo stress, how many CPUs I want to stress, 8, and the timeout. So in my case, I am setting the timeout as 300 seconds, which is 5 minutes. So it will actually spawn 8 worker process with a timeout of 20 seconds. Let's hit enter, and this should be -- CPU. On the right, have a look. The CPUs are going to be stressed at 100% because this machine is going to ensure that the CPUs are stressed. To confirm that, let's go back to our CloudWatch metrics and we click on all metrics and we go to our EC2 instance. Over here, it is telling me that indeed one alarm has been triggered. Let's go back, maximize it, and instead of average of 1 minute, let's bring it down to average of 1 minute or let's say 1 second. And let's have a look at the graph for last 5 minutes itself. So once it starts to point, we will start to see that how much is my CPU being actually stressed. Alternatively, CloudWatch Alarm generally almost work at real time. However, to get the actual picture, if in case you have to, you can directly open the task manager of your instance and have a look. Because my timeout is for 300 seconds, my CPU is going to be stressed for 100% for the next 300 seconds. Using those tools, you can go and check the stress on your machine and you can ensure that indeed your alarms are working the way they should be. In ideal scenarios, whenever you see the CPU utilization go up, it generally means that there is heavy network which is coming into your system and your machine is trying to respond to that. So in ideal scenarios, if everything is working the way it should, whenever the CPU load increases, you will see that the network in and the out is also increasing subsequently. So let's go and refresh it once again. And let's expand our CPU utilization and let's go for the last 1 hour. So if we see this over here, we are indeed going to see the graph which should show us that my CPU, which was generally always at 0%, has suddenly increased. My CPU stress test is still working, so let's just wait for it to complete. This also will be your lab assignment, which you have to do and install the stress tool inside your machine. Please remember not to give the timeout to a very heavy interval because this is not a recommended thing. However, just for the testing purpose, you might want to introduce this tool. After it is done, you will have to go and remove the tool so that it is not used by anyone else. At this moment, let's wait for the task to get completed so that we can have a look at the CPU utilization at that moment. At this moment, let's go back and have a look at the resource. As you might have seen, my second alarm also has been triggered, which means my CPU is indeed going above 90% at this moment. Let's go back and have a look at in alarm. And at this point, I'll see that both the alarms have been triggered and the action, whatever was supposed to be taken, has been taken. Once we click on the alarm, we are going to see that my CPU alarm, which is set for 90%, and my CPU is almost hitting 100%. And the reason for 100% is the stress tool. So once the tool has completed the job in 300 seconds, I'll see my CPU again goes down. To confirm the instance, let's just go and give uptime, and it is telling me that the number of users, and since the time, the instance is up, and whatever is the resource or the CPU utilization at that very moment. This is a testing of our CloudWatch alarms, and eventually my alarms are going to go into OK state once my CPU utilization goes down below the threshold. Our next step will be to go and install the log groups inside my instances. This has to be done in case I want to view the logs of my instance, whatever is happening inside the instance at that very moment. A use case for it is I have a production instance which is working. If there is some issue with the instance, I am not supposed to go inside the instance, log in into the instance and check the logs of the instance to figure out the error. Because in the production environment, no one will have access to the instances. Rather, if you need to go and check the logs of the instance at that time, what can be done is you can go and check the logs inside something known as your CloudWatch logs. The logs will be shown to you inside your logs group over here. Right now, I don't see any log group, and the reason for that is my instance does not have a log group attached to it. So for this step, we will be taking services or the help of services which are IAM, SNS, EC2, and CloudWatch. The first thing that I need to do if I have to work on CloudWatch Alarm is to go and create a policy in IAM, which will go and support the CloudWatch logs. For that, I will have to go to my policies and I will have to go and create a new policy which will support my EC2 configuration with CloudWatch alarms. Thus, for this step, let's go and create a policy. A policy in IAM is the set of rules or conditions which you are setting for any user or role whosoever will be attached to that policy. There are two ways of creating the policy. It can be via the visual editor or via the JSON console. We are going to use the JSON console because it's more configurable using the JSON. However, you are free to choose the visual editor also if in case you want to. Choosing the JSON, I'll just go and write my statements. So let's do that. Once the policy has been set, I will click on Next Tags. I can choose the tag if I want. And in the next step, I will give this policy a name. Let's call it as EC2-CloudWatch-policy. And I will click on Create Policy. Doing this will go and create a policy for me by the name of EC2-CloudWatch-policy. Once this is done, we will have to go and create a role for us, and that role should be configured on my EC2 instance using the policy that we created just now. So I will click on EC2 instance, next the permissions, and I will select the policy that I created some time back. So let's go and create a role by clicking on Create Role. Then this policy has to be used by EC2. And here we will go and search for the policy that we created some time back, which was EC2-CloudWatch-policy. Next tags, here I can give a tag if I want. And I can give it a name. So let's call it as ECT-CloudWatch-online. And I click on Create Role. Once the role has been created, I will have to go and attach this role to my existing instance, which logs I want to monitor. In this case, because I already have an instance, so I will choose that particular instance itself. So for that, I will go into my instance and make a connection with that instance. Before that, we have already created a role. We are going to attach that role to my instance by clicking on Actions, then Instance Setting, attach or replace IAM roles, and I will give it the role that I created some time back, which was EC2-CloudWatch-online. This is to ensure that my instance can now go and perform the actions on CloudWatch as required. Next step will be to go and create a user which has to go and attach with my instance. This is required because my log group or the AWS log agent, which is deployed inside my instance, will have to go and use the configurations of that particular user to upload the logs to my CloudWatch logs. For that, I will click on Add User and let's call it as CloudWatch-agent. I will be giving it programmatic access, and I will be going and giving it the access for SSM agent. So for my case, I am giving it full access. However, you can go and give the access based on the use case that you have. So I'll just go and give a tag over here, review and create the user. Now that I have the access key and the access key ID and the secret key, I can go log in into my instance and first of all install AWS CLI. Once it is done, we will go and run the update distribution package. Once it is done, we will install the CloudWatch agent required to collect the logs from my instance and send it to my CloudWatch. So for that, I will just open the link, which is you can pause at this moment to get the address which I used for my Ubuntu instance. Typing ls will show me that I indeed have my Python package present. Next step will be to go and install Python 2 inside my machine. Once it is done, I have my agent, which is a Python file. I will have to go and install it by the command and give the region, which in my case is AP-South-1. Running this is going to go and automatically do all the checks for me, and it will start to install whatever softwares and programs are required for myself. Doing this will also ask me for certain configurations which can be entered on the terminal itself, like what we are going to do now. At this point, it is asking me for the access key ID, which I already have, which I'll be providing. Secret access key. Region name is AP South 1. Output format, I'm putting it as table. It is asking me the path where I want to put the logs. I'm keeping it this itself. Log group name same. I want the instance ID itself for the logs for better understanding for myself. I want it in this format. So I am setting 1. Either you can select this format or this format or this format, depends on you. I want the start of the file. I give the location and I give N. Doing this should have configured the CloudWatch agent for me, and the logs will start to show up for myself inside the log groups present over here. In some time, I will see that the log group actually started to appear. And if I click on that log group with my instance ID, let's go back and have a look at the instance ID. It is -ending in OD7, and that is what I see here also. If I click this, I will see the logs of my instance have started to appear over here. So these are the real-time logs which are being shared to my instance at this very moment. The time over here is in the time zone of the server. For instance, if I want to check that, I can go and type time date CTL, and it will tell me that the time is this particular thing, which is the time that is being shown to me over here. So if you see, whatever logs were there for the instance, when I started working on it, starting with installation of Docker and all the things, this is present over here inside the logs. This is how we go and configure our CloudWatch logs inside AWS. If in case you want to go for the new logs, you can just go click on resume, and AWS will start to show you the logs in real time. Also, it will automatically keep on updating the logs. Going back to my alarms, I see that one of my alarm is in OK state, whereas one is still in alarm state. And the reason for that is my CPU would have gone way below 90%. Let's click on the CPU and check. It would have gone up and then it basically came down, and right now it is at approximately 8%. Whereas my second alarm was configured for 2.5%, and my CPU is still above that. So for that reason, it is telling you this red line actually means the alarm state. This means that at this time it is insufficient data, or maybe you didn't even create the alarm at that point of time. So for some time it was in green state, which means my alarm was never triggered, after which it went into the red zone, which means from here to here, which means the alarm was triggered, followed by again a green zone for this particular time, and then followed by the red when my alarm is again triggered. This is how we work on the CloudWatch alarms, and we can trigger the CloudWatch alarms, or we can create the log groups, or we can go and monitor the logs, alarms, and the metrics in CloudWatch. Let's go and do one last thing inside CloudWatch, which is CloudWatch Events. When we were talking last about CloudWatch, we said that we can go and monitor the logs using metrics. We can get some insights out of it using logs. I can run some condition on it based on alarms. And finally, I can create an event. An event inside AWS is a condition that has triggered. For example, an instance starting, or an instance stopping, or an instance terminating, or a bucket being created, maybe a bucket being deleted. All of these are example of events. You can either go to events by clicking on CloudWatch Events and Rule. However, now AWS has renamed my CloudWatch events to Amazon Event Bridge. So for that reason, we will go type Event Bridge on the search window, and I see my Event Bridge coming up. I will open my Event Bridge and I will create an event in case my instance goes into stopped state. For that, we will click on Create Rule. I will give a name, let's say instance-stopped, and I will say event to be and I will create a pattern out of it. And this pattern will be via a service. The service provider will be AWS. The service will be EC2. And my event type will be whenever my instance state changes. And that can be on a specific state, which can be, let's say, whenever the instance goes into stopped state. This can be for any instance, or you can give any specific instance ID also. I am giving any instance. So basically, I want to be informed if any of my instance goes into stopped state. Next step will be to either select a topic or any of the categories provided over here, the most popular of them being SNS topic, SNS queue, and Lambda. And I will choose my topic that we created initially. Now, if I click on create, and if in case any of my instance goes into stopped state, AWS will send a notification to me to test it out. Let's go and stop the instance now. However, please remember, in production data or in production, you are not supposed to start the instance unnecessarily. So let's stop the instance, and we will in some time see that we get a notification from AWS telling that this instance was stopped. As you can see, I got the email for the instance being stopped over here. Now you are free to go and create as many events as you want. If in case you want, you can disable the event temporarily. If you want and you don't need the event anymore, you can go and delete the event, which means my instance is no longer being monitored. However, the alarms are still there. So if you go and terminate the instance, if it is not required, you should ideally also go and delete your alarms which are present. So I'll choose this action, delete alarm, and delete the alarms. Remember, deleting the alarm does not mean that the metrics is gone. The metrics will still be there for the instance for some time. So as you can see, this is the performance of my instance over the period. That's it for this lab session of CloudWatch, where we went and we monitored and we had a look at the tools for monitoring inside AWS CloudWatch. In this lab, we understood how we can use CloudWatch to collect, which means we can collect the metrics and logs from your AWS resources, application, and services that runs on AWS. We saw how we can monitor the CloudWatch events or CloudWatch properties, or how we can visualize the application and infrastructure with CloudWatch dashboard. You can correlate the logs and the metrics side by side to troubleshoot and set alerts with CloudWatch Alarm. We understood how we can act using our CloudWatch events, in which case we can automate the response to operational changes with CloudWatch events. And finally, we understood how we can analyze the logs by up to 1 second metrics, extended data retention, which can be for 15 months with real-time analysis with CloudWatch metrics. This is it in the lab for CloudWatch. You will now move to the lab session, wherein you will be performing the same task that we have done along with the lab manual. Once you are done with the job, you can go and delete the CloudWatch events, the logs, the log groups, the alarms, and the resources that you created for CloudWatch.